Hello, everyone. My name is Danielle Fender, and I am presenting Disability in the Science Classroom. What is disability? The Americans with Disabilities Act considers a person to have a disability if she or he has a significant impairment that interferes with a major life activity, such as walking, seeing, hearing, learning, speaking, breathing, standing, lifting, or caring for oneself. As teachers, we see disability in the classroom in a variety of ways. The most common way that I see disability in my classroom is through learning disabilities. Why did I choose disability? According to the California Dashboard, students with disabilities are the lowest performing group in both ELA and mathematics at my school site. Next year, science is going to be represented on the California Dashboard. Reflection of equity practices is vital to ensure that all of our students have the opportunity to succeed in their current academics and at any future education they hope to receive. I currently have 8 students in the Resource Specialist Program receiving special education services. 7 of those students are enrolled in one class period. In this lesson study, the lesson being observed is being used as an introduction to reaction rates. The lesson consists of a laboratory component where students will be working collaboratively in small groups to collect data on 3 different factors that affect reaction rates. Students will be investigating the effects of agitation, which is stirring, on reaction rates, surface area, and temperature. Once students have completed data collection, they will begin the video production portion of the lesson. During this section, students will work collaboratively to research one factor and create a video that illustrates why the observed effect occurs. During the analysis portion of this assignment, I used the Mid-Atlantic Equity Consortium's Criteria for an Equitable Classroom Equity Audit Checklist. This is a picture of that checklist. In this particular analysis, I will be focusing on the instructional strategies listed on page 3. One of the strategies that I witnessed in this lesson was instructional strategy number 5. Does the teacher use instructional strategies such as cooperative learning to accommodate varied learning styles and backgrounds? Modeling expectations. An important aspect of introducing laboratory procedures is to model my expectations to my students. This modeling allows visual learners to observe what is expected of them during the laboratory activity. It also allows auditory learners to hear what is expected of them throughout the laboratory activity. I also have written procedures printed at each of the lab stations so that if they learn from reading, they can learn what to do through those procedures. What this modeling also allows students to do is ask clarifying questions if they are confused on any of the procedures for the activity. This video clip shows me as the teacher modeling my expectations for the procedures to my students.
Completely without stirring. For the stirring, at your lab station, you're going to use one of the beakers, just one. You're going to fill it up with 200 milliliters. So you're going to fill it up to the 200 line, just with regular tap water. And then you're going to put one of the sugar cubes that's at your lab station into that water. Now, as soon as it hits the water, the other person in your lab group is going to want to start a timer. Okay? Now, with stirring, you do not want to be making tornadoes. This is bad. Okay? One, you could break my stirring rod, and I would be unhappy. And two, it's not going to take very long. It's going to be like 5 seconds, and then you're done. Okay? So what I would ask that you guys do for stirring is to do a slow, steady stir. Just a slow, steady stir to get that water moving. Okay? I do not want to hear clinking. You do not need a vortex down the center of your beaker. Okay? Please, 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 just slow, steady stirring for the stirring situation. Okay? So that's what you're going to be doing for the first situation.
Another instructional strategy from the Mid-Atlantic Equity Consortium's Criteria for an Equitable Classroom Equity Audit is instructional strategy number 4. Does the teacher promote cooperation and integration of students through activities which help students to work together more effectively? Student collaboration is a large part of this lesson. Students will first work together at the lab stations to collect their data. During this time, I, as the teacher, circulated the classroom to engage in conversations with my students. It is through this engagement that I can ask probing questions to my students to accelerate the learning of the advanced learners. I can also correct any misconceptions students may have about their observed results. In this video clip, you will see students working at the lab stations and I, as their teacher, clarifying directions and answering questions to one group in particular.
It'd be between two numbers here, okay?
These students are working together to collect their data, and I am clarifying directions to this group as they had one particular question about temperature. The expected outcomes that I had for my students was that they all meet the learning objective for this lesson. The learning objective that was posted was students will be able to identify the effects of agitation, surface area, and temperature on reaction rates, and explain how the observed effect is achieved at the molecular level. Through conversations, I was able to ensure that most of my students understood how the three factors affect reaction rates. Through the student-produced videos, I am able to ensure that students understand what is happening at the molecular level and how that affects the reaction rate. One piece of student work that I have here is a video that illustrates the effects of surface area on reaction rates. This is a student-produced video and includes voiceover of students explaining what is occurring at the molecular level to the reaction rate.
I'm Krista.
And I'm Jasmine.
And we have surface area effect on reaction rates. What happens? The more finely divided the solid is, the faster the reaction rate occurs.
Why does this happen? Two types of molecules can only bump into each other at a liquid-solid interface on the surface of solid. Rates of reaction increase according to the frequency of collision between the reactants. A decrease in particle size causes an increase in the solid's total surface area. When a chunk of solid substance reacts with a liquid or gas, only the particles on the surface of the solid comes into contact with the other reactant. Our example, a sugar cube is granulated sugar tightly compact. The outside of the cube is more exposed to the water, which slowly breaks up the compactness to dissolve the sugar cube easier. The granulated sugar is already spread and exposed to the water at the same time, which makes all the individual crystals dissolve faster.
This video explains our topic more in depth.
This video is student-produced and proves or supports the claim that students met the learning objective.
What happened?
Here is a second sample of student work on the same factor on reaction rate.
Reaction rates by Angelina Cassidy and Estefania. Essential question. How does surface area affect reaction rates? Example: sugar cube versus granulated sugar. Which will dissolve faster? During a lab, we tested how long it would take for a sugar cube to fully dissolve in water while stirring at a constant rate of speed. We discovered it took about 197 seconds for the sugar cube to fully dissolve. We then tested the same exact thing with using granulated sugar and stirring at a constant rate of speed. We discovered it took about 128 seconds for the sugar to fully dissolve, which was less time than the sugar cube. Why did this happen? Well, since a sugar cube is tightly compacted, there is less surface area exposed to the water, which causes the sugar cube to take a longer amount of time to dissolve. Whereas granulated sugar has a higher surface area, which allows every grain to be exposed to the water all at the same time, causing it to dissolve faster. All in all, we concluded that the higher the surface area, the quicker the reaction rate. The end.
Students did have a choice in how they wanted to present their video. In Sample 1, students chose to make a PowerPoint and present it through iMovie. In Example 2, students used a whiteboard and stop motion to create a video that also had the same information to prove that they met the learning objective. In the future, some recommendations to improve this lesson would be to assign lab partners. In the assigning of lab partners, I can couple advanced learners with a lower performing student, and that would cause a benefit to both of the students. One obstacle I see with this change is students may not be comfortable with another student who has a different learning level as them. Another recommendation that I have for this lesson is to apply a virtual aspect or a virtual lab so that the students can revisit the lab at a later time. They can observe the effects multiple times and take their time analyzing the results. Another plus for adding a virtual aspect would be for students who are absent on the day of the lab. If I had a virtual component, those students would still be able to collect data, even though they were not here in class on the day it was done. Thank you for watching my presentation.